All right. Good morning, everybody. So we'll just do a brief overview again on the lab. Is a Gen 3 up? What now? What's there now? Are you not connected to the network?
Apply. Okay, he's up.
Please, create your lab. Gabriel, have you connected? Leave him now. He knows what to do now.
You know what to do? Yeah, you should project then.
Open your lab. Zach, open your lab. Is your lab open? This thing is not your lab, please. So everybody, hold on. Everybody, look up. Your Gen 3 is up. God bless. All right. So those of us that have gone far, you join us where we join, right? Those of us that have not done anything, can we concentrate? So the aim of the lab was to have a connection of maybe 4 or more routers. Are we following?
Yes.
This is me adding them on the fly. 4 or more routers. We interconnect them. So as I'm doing it, if you have not done it, kindly do it. This time around, since my routers are small, I'll do a mesh where each router will have a link to the neighbor. I think this is the last. Yes. I hope it's clear. This will be my R1. I hope you are looking up. This will be my R2. This will be my R3. I'll label the links properly. This will be my R4. Just 4. I'll delete this one. Okay, so R3 to R3, R2 to R2, R3 to R3. God bless. Have you started? All right. What's the next thing? Assign the IP address. All right. So in doing that, I'll turn on my routers so that as I'm assigning the IP address, I'm also doing the configuration. So I'll use the text tool. So from my R1 going to my R, let me start with R1 to R3, that's my eta 1. R1 to R3, I'll give it the network of 192.168.0.0/30. I'm using a /30 since it's what? Just a point to point. There's no bridging here, right? The link from here is going directly to this router. So I'm going to do that. So my R1, I'll console to my R1. All right. So first thing, when I console to my R1 is to do what? Identity set name is equal to what? R1. Then IP address add interface eta 1, isn't it? So this is the network R1 to R3. So the address is equal to 192.168.0.1 for the first usable IP address with the subnet mask or the CIDR number. Then I'll put a comment. This is to R3. Okay. With that in mind, I can then label my link. So this is .1, isn't it? So I'll configure the other partner link, which is in R3. So on R3 now, system identity set name is equal to R3, right? So in R3 now, IP address add interface. Remember on my R3, it's eta 1, right? It's eta 1. So interface is eta 1. Address is 192.168.0.2/30. Comment is to R1, right? So I can then continue again from R3 since I'm already in R3. So I'll say R3 to R2. I'll give it 192.168.0. What's the next network? 4.4/30. So R3 to R2 is on eta 3 of R3. So that means on my configuration, I'll do IP address add interface is equal to eta what? 3. The address is equal to 192.168.0. We are on the 0.4 network, so the first user is 0.5/30. Comment is to R2. Then I'll label it. I didn't label this other part. This is .2. .2. So this one now is .5, right?
Yes.
.5. So if that is .5, here will be .6, isn't it? So reflect that now in configuration. So on R2, admin, system identity set name is equal to R2. On R2 now, remember it's eta 3, right? Going to eta 3. So IP address add interface is eta 3. Address is 192.168.0.6 slash what? 30. Comment is to arrow 3. Right? So we can continue again. Since we're on arrow 2, you can say from arrow 2 now to arrow 1. From R2 to R1 can give you 192.168.0. The next network, .8/30. So .8 network now, R2 can be the first, which is .9, isn't it? So in configuration, IP address add interface is eta 2. Interface is eta 2. The address is 192.168.0.9/30. Comment, that's to R1. Then we'll head to R1 now. If here is .9, here will be what? .10. Right?
Yes.
So on R1, IP address add interface is eta what? Address is 192.168.0.10, isn't it? /30. What's the comment?
R2.
To R2. To R2. All right. So since we are in R1, we have already done for eta 2 and eta 1, right? So we should do for eta 3 now, right? So R1 going to R4 would be 192.168.0.12/30. Okay. So on R1 we're on the 12 network, so here will be .11, isn't it? .11 on R1 on eta 3. So R1 IP address add interface eta 3. Address is 192.168.0.13/24. Comment is
24, 30.
Thank you. 30. Comment is to R4. Then head to R4. On R4, system identity set name is R4, right? So on R4, it's eta 3. So IP address add address is 192.168.0.14. We'll still do that one now. Anyone can come first. Interface is ETA 3, right? Are we following? This is, sorry, the address is wrong. We are on the 12th network. This is supposed to be 13 and I did 11.
No, I think in the listing we got it.
Okay.
It's just here that we wrote.
R1.13. Okay, we got it. So here will be dot what? 14. And the comment would be to what? Arrow 1. So let me just correct this. Dot 13. Then here's a dot 14. So since we're in R4, R4 has a link going to
R2.
R2. Okay. R2. So we can give that 192.168.0.16/30. So that on that link, R4 would be dot 17. And R2 on that link would be dot 18. So let's do that in configuration. That will be IP address add address is equal to 192.168.0.17, right? /30. Interface is equal to ETA 1. Is ETA 1. Is ETA 1 to R2. Is ETA 1 as it here.
Okay.
Then, since it's going to R2, right? We'll go to R2. I hope we are looking up. Everybody's quiet. IP address add interface. On R2 is ETA 1 and is dot 18. So on R2, interface is ETA 1 and the address is what? 192.168.0.18/30. Comment is to R4. Then the last link is the link between R4 and R3, right? So R4 going to R3, 192.168.0. After dot 16, what do we have?
17.
No, now the next network.
20.
Dot 20. So since I'm on R4, I will head over to R4. R4, that will be IP address add address is equal to the first IP. The first usable IP in that network is 0.21/30. Interface is ETA 2. Comment is to R3. Okay, then you can label it over here. This is dot 21. Dot 21. So that the top here now will be dot This will be what? .22, right? I can come to R3. I can come to R3. So IP address add interface is eta 2. Address is 192.168.0.22/30. Comment is to R4. So at this point, we are done with configuration. So what do? We start testing, right? Isn't it?
It is.
So I'm on R1 now. On R1, my IP address is if I could, let me reduce. How much of this can I shrink? Okay, I just hope we can see. On R1, my IP address is .10 on eta2, .1 on eta1, .13 on eta3, right? So we'll just ping our neighbors. So ping, I'll start with eta1. On eta1, the neighbor is .2, right? So ping 192.168.0.2, and it's responding, right? Isn't it? On eta2, my neighbor is .9, right? So I'll ping .9, and you can see 2 is responding, right? On eta3, my neighbor is .14, and I'll ping .14, and it's also what? Responding. So we'll go to eta R2 up here. My IP address on R2 is .6, .18, and .9. So on eta1, which is .18, my neighbor is .17. So on R2, I'll ping 192.168.0.17, and it's responding, right? On R2, my neighbor is .10, which we ping from R1 before, right? But we just still ping again from here, .10, and you can see it's also what? It's also responding. So on R2 again, on eta3, my neighbor is .5. I'll ping .5, and it's also what? Responding, isn't it? So that means we are good in R2. Go to R3. On R3, my IP address on eta1 is .2, on eta2 is .22, on eta3 is .5. So I'll ping my neighbors. Ping 192.168.0 on eta1. My neighbor is .1. So I'll ping 0.1. That responds. On eta2, my neighbor is .21. That is also working. And on eta3, my neighbor is .6, and it's also what? Working. Then last but not the least, R4. On R4, my IP address on eta1 is .17, and my IP address on eta2 is .21, and my IP address on eta3 is .14. So I'll ping my neighbors. I'll ping 192.168.0. On eta1, my neighbor is .18. So I ping .18, it works. And on eta2, my neighbor is .22. I ping .22, it's also working. And my neighbor on eta3 is .13, and it's also what? Working. So that means we've confirmed that we have both layer 2 and layer 3 connectivity, isn't it? Layer 2 connectivity, the link, right? As soon as you draw the link from here to here and it's showing 2 green, 1 green up here, 1 green in the other end, it means layer 2 is working, right? Layer 3 is the IP address, and now I've confirmed that all of them are working. So at this point, though our network is a full mesh network, meaning each router has direct connection to the other neighbor, right? What if something were to happen? Like for instance, if R2 wanted to talk to R3, right? The message would go to .17, isn't it? But what if this link between R2 and R4 is disconnected? What do you think would happen? R2 will no longer be able to talk to R4. Both directly or indirectly. Because if I look in R2 now, if you look at the routing table, IP route print, do you see that I have the network? What's that network? .18 and .17 is .16 network, isn't it? Now in .16 network, do you see is dynamic and is what? Connected, but the A flag is not there. What does A stand for? A stands for what? Active. That link is no longer active. But remember, it's dynamic because it was added when we added our IP address, isn't it? It's connected because it's a direct layer 2 link on the router. That's why it's showing connected. So it means at this point, if I ping 192.168.0.17, isn't it? .17, and that's the IP address of R4. This it. No route to what? To host. It means that even if R2 in layer 2 can go through R3 and come to R4, or it can go through R1 and come to R4, in configuration, we have not reflected that that kind of routing. True or false? True or false? Uh-huh. So at this point, what do we do then? We now engage in static what? Routing, isn't it? Where we tell R2, please IP route, that's the command, IP route add. If that's the destination address, if you are trying to reach, you put the address of the network. For example, R4 now, that's 192.168.0.16, isn't it? It's 18 and 17 now. 18 and 17 now, all of them are under the .16 network, right? So we'll put it in the destination address that if you're trying to reach 192.168.0.16/30, right? Gateway. So it can now pass through .5, right?
Yes.
Isn't it? It can pass through .5 now. So we can put 192.168.0.5. Do you understand?
Yes.
Meaning, anytime you want to send a message to this destination, right? You can pass through what? .5, pass through R3. But remember now, we have both R3, .5 and .10 can talk to R4. True of us. So in that case, we can load balance it by using a comma and putting in the second IP address. 192.168.0.10. Do you understand?
Okay.
0.10. Mean what we have just done now, if we apply this configuration, we call this equal cost multiple path routing, ECMP.
If you are doing for a big topology, are you still going to pass through? Like the larger one, like this one you did, are you still going to pass through the process?
If you are doing static routing, you obviously have to do it.
Okay, for static.
like
Okay, automatic you can
the one you gave us that's containing like
10 routers.
Yeah,
So
if
if
you are to link a 10 router topology and there is no dynamic routing announcing the routes, that means for each router to talk to the other, you have to what? Tell each of them. You have to tell R1 how to get to R2. For example, if from R5, now in this our 4 router topology, from R5, R6, R7, R8, R9, R10, R1 does not have any direct connection with them, right? What do you do in order for R1 to get to those networks? You have to manually what? Come to the router and add a route for it. Add the destination address and the gateway. So, like for example now, I have added the destination address of 0.16/30 and I've added the gateway, right? Though in this case, in adding the gateway, I added 2 different routers as the what? Gateway. So what will happen? The message will be split into what? 2. Some messages will pass through this router. Some messages will pass through what? The other router. And in that case, you have done what? Load what? Balance. Do you understand? For example, let's look at this scenario. You are trying to download, you're browsing from under R1, right? Your computer is under R1. You're trying to download something from R3, right? Now, the link speed between R2 and R1 is 100 megabytes per second, 100 megabits per second, right? 100 Mbps, right? And the link speed also between R4 and R1 is still 100 Mbps per what? Second. The link speed between R4 and R3, R2 and R3 can either be 100 Mbps per second or even 1 gig and above, right? But if your message was passing through only one router, even if you have 2 links to that same place, it means that you only be getting the speed of that connection. Are we following? So that means if our message was only passing through R2, for instance, what will happen? The speed that our laptop or whatever we are using to access that network here will be at what? 100 Mbps per second. But when we load balance the link in this scenario here, we enjoy the link speed here, and we also enjoy the link speed what? Here, bringing our total throughput to what? 200 Mbps per what? Second. Do you see where we utilize it? We load balance it. We share the load. So if you look at my routing table now, IP route print. Do you see it? I have route number 2. It's both active and it's static. The static means it was added manually, isn't it? For any packet going to this network, it's going to pass through who? 0.5 and 0.10. Then the way the router splits it is by ratio. Since this is 2, the ratio is what? 50/50. So there are scenarios where you want to prefer 1, even if you are load balancing it, but you want to prefer 1 more. So you can add one of the links maybe like 3 times. I can repeat this IP address 3 times, then add this one in the last one. What does that mean? It means that this one will be preferred 3/4, right? While this other one will be preferred 1/4 times. Do you understand? So in that case now we'll split the packet into a 75/25 ratio. Are you seeing it? Are we seeing it? Is it making sense? Now, though I have configured this link over here in arrow 2. You know that we still need to do the same thing in arrow 4 to complete the connection, right? Connectivity is what? Two-way. I talk to you and you what? Talk to me. If I talk to you and you don't know how to talk to me, do we have connection? No. So that means in order to complete this configuration, we have to head to arrow 4 and repeat that same what? Thing. Now in arrow 4, trying to get to that network of 192.168.0.16 will pass through .22 and what? 13. Now, the same thing that we did in arrow 2 again now. We had to get to this network.
But the network will not be .16 again.
It will still be .16 now. It's trying to get to .18. Right? .18 is inside the the network of 192.168.0.16. So it's still .16 we are referencing.
So why are you calling the network of that link from 2 to 4?
It includes both this IP address and this one.
So what that means that if you cannot get to this link, use this gateway.
If you are trying to, the destination address, if you are trying to get to this network, right, pass through who? Him, the gateway. That's what it means.
So you must call a network that
Yeah.
is affected.
You must call a network address. So, for instance, now I want to call a single IP address. I can now use the IP address of that IP with a slash what? 32. A slash 32, what does that mean? A single IP address only, isn't it? True now, isn't it? While a slash 31 is an IP, two IP addresses, one for the network and one for the what? Broadcast. While slash 30 is 4 IP addresses, one for the network, one for the broadcast, and 2 usable IP addresses, isn't it? So that means if in my routing table now, I wanted to say if arrow 2 wanted to get to only .17, right? Either I will remove the slash 30. If I remove it, the router by itself automatically adds a slash 32. Or I put that slash 32 by myself to refer to a single what? Host. Do you understand? In routing, you must refer to what? The network. You must refer to the network. In routing, you must refer to the network. So that means if you are trying to just refer to a single host, you now have to utilize the what? A slash 32 as the what? Network. Or maybe you have a slash 24 and you just want to reference some of the people inside that slash 24. I don't need to reference the whole slash 24. I'll just reference that slash what? That network that can cover all the IP addresses that I need. Is it making sense? Is it making sense? You need to understand these things before you now employ the dynamic routing protocols to help you out. Because if you don't know what to do and you start using dynamic routing protocols, if they begin to run into issues, you will not know where to what? Look for the problem because you don't even know what is even happening. You just
Dynamic one looks more simple.
It looks more simpler, but in production environments, they can run into issues that you must know how to route manually first in order to what? Resolve the issues. For example, if you are writing a networking exam, they will give you a routing table like this. They'll give you a routing table that looks even bigger than this, right? They will not ask you, a packet is trying to get to this destination. Which of the routers do you think that packet will pass through based on the routing table? Do you follow? Now you now need to think by the routing table. Look at it and interpret it the way the router is supposed to what? interpret it. For example, if we look at this routing table now, any packet that is trying to get to 0.16, where do you think it will pass right now?
Which packet?
A packet is intended to go to 0.16 network. Where do you think that packet will pass through? I'm asking us now.
0.5 or 10 or both. Half 50-50.
It will follow both of them 50-50. What if I remove this pause? And I resume that link. Now, where do you think the packet intended for that network would go through?
Go through the 17 and straight.
It will go through?
17. There will be no need to go around.
It will go through .17. Can you back up that answer with a reason?
Because there is no need for, it's the shortest route to the destination. There's no need to go around.
Back it up with what you are seeing here. Forget about this place. Are you seeing any .17 here? I can't see it. So that means you're inferencing something from somewhere. In exam conditions, you don't know where that thing is coming out from. You're only seeing what they are showing you. And this is what I'm showing you. Where do you think? Back it up with reasons. The simple answer is, in Microtik, there is to be a flag for the preferred link. And that flag is what? The A flag. Right? So I can see that network I'm looking at, I have two different routes to it. Route number 2 and route number 3. Right? I'll now need to compare those two routes and see which one will be more preferred. Though Microtik is already telling me that this one is more preferred by the A flag. The active flag, meaning it's going to be passing through that one, which is passing through ETA 1 directly. No IP address. It's a directly connected ring. Why the second one is just what? Idle. There's no active flag on it. That's in Microtik. But other routers will may not give you this information like Microtik will do here. So how do you identify which one is the shortest? We now go to what we call the administrative distance. Right? We talked about the administrative distance the last time we went through routing. Now, which of them has the smallest administrative distance? The directly connected route, isn't it? It has a distance of 0. That's smallest. So that's why it's preferred. And the only route that can have an AD of 0 is directly connected route. When you add a route manually, the smallest in AD that you can assign to that route is equal to 1. So in this case now, we cannot do what we call backup links. For instance, this already is a backup link, isn't it? What we have done here in this configuration now is a backup now. If this link fails, it will back up to this one, isn't it? Yes. Based on the AD. Now, what if you actually had another link again going to that network, but you didn't want to load balance it with these two here? No, remember this 2 here is load balanced as 1, right? What if we had another third link, maybe going to one router, then going to that same place, and wanted to use that one as the final backup? That's backup number 2. Number 2 now. We have one active, one backup. Now we're adding another backup number 2, right? Now, if we add that link, but we don't want, if these two are up, we don't want packets to go through that last backup. No, we don't want it. We only want packets to go through that last link when this one has failed and this other two has failed. That's when we want packets to go through. You wonder which kind of scenario would you do that? For example, if you are using modem, right? If you had an internet connection with modem and you had an internet connection with fiber, which one would you prefer? Fiber. What if you had your hotspot? Fiber, you have mobile hotspot, and you have modem. Which of them would you prefer? How would you prefer them? Fiber first, followed by hotspot, then what? Finally what? Modem. So in that case now, modem can be like the last backup. Do you understand? Now, how do I make that modem link the last backup in configuration? By the time I'm adding the second static route for that modem link, right? I'll make the distance to be what? Greater than that one as a floating, we call it floating route. So I just record that command. I just go to what? To increase the distance, change it. Distance is equal to, you can put something like 100. Right? Way higher. Isn't it? As far as the administrative distance is higher than some other route, it will not be preferred because AD is from lowest to what? Highest. Does it make sense? Now, if you have understood this now, you can now begin to now think of what? The dynamic what? Route. The dynamic route is just, what will it be helping you to do? If you, at the end of the day, dynamic route is to configure a route to that network, isn't it? That's the end goal of the dynamic route that we have been doing. The end goal is that at the end of the day, it should install some routes to the network. So for every network that your routers are advertising, inside this router or inside another router, they will be installing the static route to that network. But in that case now, it's no longer static route. It's now what? Dynamic, because it can be added on the fly and it can also be what? Removed on the fly. Right? Is it making sense? So at this point in time now, we can then go over how we now set up what? OSPF. We are using OSPF for our dynamic routing. Now, in OSPF, I said from our last class, what's the first thing to do? It's recommended that your router has an IP address that is called the loop backward IP. What's the reason for that? Pay attention before you write. Pay attention so that you understand it. What's the reason for that? If you look at this routing table, now, for instance, the link between R2 and R4, the IP address is on R2 is .18, isn't it? And the IP address on R4 is .17, right? What if this link failed? Let's say it's fiber link and something caught it in the middle. It means that R4 is no longer .17. True or false? We can look at it in configuration. I'm on R2. I'll disable the link on Ether 1. I'm going to disable it. So interface, Ethernet, Ether. Okay, interface print. So we have Ether 1 there, right? Ether 1 is number 0, isn't it? Isn't it? I'm going to disable that. So disable number 0. I'll print again. So you can see the X flag on number 1 on Ether 1, right? So it's now offline. Now, if I come back to my routing table, IP route print. Do you see now that I no longer know .18, .16, that second link that was coming as the connected route? This is the one that we added manually now. Let me remove that one for the moment, please. IP route, remove number 2. Now, do you see now that I no longer know that network, right? Even if that in my IP address print is written there, isn't it? That .18 is inside my routing table, inside my router, right?
Well, there is something on it.
because it's disabled now. There's no link, it's not active. Since this link is no longer active, on my routing table, on that same router, that link will not be there. So there you can see now there's nothing concerning .16/30 network inside my routing table. So what if you are running a dynamic routing protocol and you are using that IP address .17 for things that you are referencing concerning R4? What do you think will happen at this point? All of them would what? Fail. Even if .14 is still up, even if .21 is still up, but because you are using .17, which is an IP address allocated to an interface that have failed, that router will become what? Offline. Is it making sense? So for that reason, we do not use interface IP address when we are talking about the IP address of a what? Of a router. It's like in reality, Zach, what is your name? Your name is what? Zach, isn't it? Name, if somebody asks you your name now, what will you tell them? Zach, right? But Mr. Godbless can be close to you now that both of you have a nickname, right? So he can call you Tim, isn't it? Or you can call him God, something like that. You will not tell me that that's the name that you are sharing, isn't it? So anytime I want to reference Zach, what will I use? Zach, isn't it? You now, when you're discussing with Zach, you'll be calling him Tim, right? But if you are to talk to me and you wanted to talk to Zach, which name would you use? Will you use Tim? No, you call Zach now, right? Because it's Zach that I will what? No. The loop backward IP. That loop back IP, we'll now use it as a global IP address that anytime we want to talk to this router, we are talking to what? That loop backward IP. The loop back IP, you'll be wondering, IP address is not an interface we're supposed to assign an IP address to. Yes, it's an interface. True or false? True. We assign an IP address to an what? To an interface. But the loopback interface is an interface that would not what? Go off. Why? Because it is not connected to an external what? Device. As far as that router is online, that loopback interface would be what? On. Do you understand? In other devices, the loopback interface, they may have like a customized interface and they call it loopback. But in Microtik, if you wanted to create a loopback interface, what do? You create a new bridge, right? Without assigning any interface to that what? Bridge. At that point in time, that interface now becomes what? A loopback what? Interface. The bridge, it will always be on, isn't it? Isn't it? When you create a bridge in a router, the bridge is always what? On. So if you assign an IP address to that bridge, that IP address now is now your what? Loop backward IP. So the first step in OSPF configuration is that each of your router should have the what? A loop backward IP. And based on that loopback IP, your what we call router ID in OSPF, or if I bring it down, if I scale that English down from router ID, the ID, that is the IP address of your router that it will be advertising to other OSPF routers. That's what they mean by what? Router ID. Are we following? Are we following? So at this point in production or even in your lab, because we use lab to simulate what the real world should look like. So that means I can form a new network from somewhere. Remember, your loopback IP is not an IP address that you'll be using elsewhere. True or false? Yeah? You're no longer answering. True or false? If I've used, for instance, 10.10.10.1 here, should I use 10.10.10.1 here? It should be unique on the network. Are we following? So that means if I say my arrow 1, is 10.10.10.1. That means my R2 will now become another one, right? So we can use 10.10.10.2. My R3 can be 10.10.10.3. If you notice very well, am I using any slash something? Am I using any slash something?
No.
Why? Why do you think so? Because it's a loop backward IP, meaning we just need one single IP address from it, right? So me putting a single IP address without any slash means it's a slash 32. Do you understand?
So if you put 32, both it will
It will go. But to shorten the process, I just put what? Just the IP address. Look at it now in configuration. If I come to R1, please look up. The first step I say is to do what? To create a loopback interface in router. What do? You create a what? A bridge. So I go to bridge, interface, bridge, add. Name is equal to what? I can call it loopback, right? Loopback. Then
please make it bold.
that thing will stress me now. No, don't worry, no problem, no problem. I think this one will be better. Let me just. Okay. Shit. So, how was that again?
Connect the bridge.
All right. IP address print. Now, we've created the bridge, interface bridge print. I've created a bridge. See it here, right? Isn't it? What's the name of the bridge? Loop back, right? Loop back. Sometimes you can use the detail, print detail. Sorry. Brief. Print brief. So just print a short. No, this one is giving us plenty information. So print brief, I have just what? One bridge, isn't it? Loop back. So I can come to my IP address and IP address add, isn't it? IP address add. Interface is now what? The loop back, right? Then I can assign that IP. This is arrow 1. So the address would be 10.10.10.1. Now, I will not put the slash so that you see it in action. Though it's microtic, but you need to understand the effect of what you are doing. Now, if I do IP address print, do you see a /32 there? Did I put it? No. But the router what? Put it automatically, because that is what is actually expected. In configuration, you have to put the subnet what? Mask, isn't it? Whether you would like to put it or not, you must what? Put the subnet mask. If you're doing a microtic configuration, you didn't put it, microtic will assume it is a what? A /32.
So if you put to IP address without the subject line, will it put the /31 for you?
How will you put 2 IP address? There's only one IP address you can configure now. One on each router now. The other one on the other one. So as you're learning, you can do what? Remember to put the /what? 32. But in case you did not put it, you know that microtic will assume is a what? A /32. So at this point in time, if we said anything, we did that on arrow 1, that means we can tell R3 that to talk to arrow 1, the IP address of arrow 1 is 10.10.10.1, because it's an IP address on that router. True or false? True or false? True. So that's the work of the what? The loop back. In configuring what? OSPF. I hope you are following. Then the next thing in configuring an OSPF is that you assign that loopback IP as the router ID of your what? Your OSPF what? Instance. And to do that, you find that in the OSPF menu. OSPF is inside routing. OSPF. Are we following? The OSPF what? Menu. Now inside the OSPF menu, you have so many sub-menus. You have area, AS border router, you have interface, MBM enable, network, sham link, area border router, other menus that you care about. But by default, the OSPF, the first thing that we are concerned with is the instance, right? The OSPF instance. So in configuring OSPF, basic OSPF, there are 2 things we need to do: the instance and the what? Network. So if you go to instance menu, we'll do a print. You'll notice that by default, there is an instance already running on each router. Do you see it? Can we see it there? Did I add anything? Did I add? No, I didn't add. By default, every router has an OSPF instance that is what? There, but it's not running. Why is it not running? You'll find out in the next step. Why are we coming to the instance menu? We're coming to the instance menu to change something. If you look at it, when you print it, do you see a router ID there? What is it set to? Unknown. Unknown. Meaning, whenever if you leave this thing like this and set it up, what will happen is that at the point where the router begins to advertise neighborship to other routers, it's going to look for the lowest IP address in your routing table. That's in your IP address table, right? So you don't know how that math may look like. For instance, maybe you configured your router with 1.1.1.1 and you configured another interface with 9.9.9.9. Which one is the lowest? 1.1 is the lowest. But you don't want that to be the IP address that you're announcing your OSPF as, right? Because it will be confusing. So what do? You actually manually change what? The router ID. And in this case, I know my router ID for my R1. So we know the number of that entry is entry 0, isn't it? Just the way we set identity. Set number 0. Either you put number and write 0, or you just put 0. They mean the what? The same thing. So set number 0. What do you want to set? The router what? ID. I want to set it to 10.10.10.1. So that if I do a print again, do you see now that my router ID has what? Changed. That's the first configuration we need to do in OSPF. Right? Right? Did you get it? Did we get it? Did we get it? The last configuration we need to do in order for OSPF to work, basic OSPF, because this one is what? Basic OSPF. In the industry, in production, the OSPF you'll be running is way advanced. Because there are some properties that we need from the advanced OSPF in order for us to utilize it. The second configuration you have to do is to announce the what? OSPF on the networks that you want to. So what does that mean? Is for instance, all our laptops here, they came with Bluetooth, true of us. Yes. But it's until you go and click receive a file before somebody can send you a file. Isn't it? Yeah. Isn't it? Yes. All our laptops came with Wi-Fi. But it's until you connect to a hotspot before you can browse the internet. Isn't it? All the routers, they come pre-installed with the OSPF instance in MikroTik, right? But before they would advertise that OSPF instance that they have created, before they will advertise it and begin to form neighborship with other routers, you need to manually go and state the network that you want to advertise your OSPF. Are we following? And in order to do that, we'll first of all head back to the OSPF menu. So we can see that I'll use the dot. Have you seen this command before? Where? In Linux, isn't it? My MikroTik was built on Linux, so some of the commands are close. So dot to go to the previous menu, right? So I'm back to the OSPF menu. Now in the OSPF menu, we'll go to what? OSPF networks. OSPF network. Now, if I print here, do you see that we don't have anything in the network? Do you understand? So do you get that explanation I just gave? Though the Bluetooth, let's assume that the Bluetooth now is the OSPF. The Bluetooth has been installed by default, right? But in order for us to receive connection from other Bluetooth devices, we need to go and what? Receive a file, which in OSPF is to tell the network and the area of the network. So since it's empty, we have to what? Add. Two of us, look up. Since it's empty, we have to what? Add. Now, as we are adding, it's just two things, network and area, isn't it? So, network. What do they mean by network? A network what? Address. As simple as that. So that means, if we come back to our topology, our network is, I'm on R1. So if I wanted to announce OSPF on only my Eta 1, right? I will reference the network on Eta 1, which is what? 0.0 slash what? 30. What if I wanted to announce it on all the interfaces? That means I will add for Eta 1, Eta 2, and Eta 3. I'll be adding each of them their network, right? Or I can reference the all IP address network, which is what? 0.0.0. So if I put here on my network that the network is 0.0.0.0 slash what? 0. It means all the networks that are inside this what? Router, any interface on the router would be announcing what? OSPF. I hope it makes sense. Does it make sense?
Instead of adding it one after the other.
Instead of adding it one after the other,
Just do all.
this is what all, meaning all of them will be entering as one. Normally, we're supposed to be referencing each network. That's the proper way of, in production, you don't just announce OSPF on all your interface. Because the cybersecurity people will tell you that an attacker can come and plug something to your network, right? And announce another bogus network, and your routing table would be destroyed because you are announcing OSPF on all your interfaces. So you only announce OSPF on the interface that you know should be what? Forming OSPF neighborship, right? But since we are in the lab, we can be using the what? The all network IP address. I hope you understand. I hope you understand. The main thing is for you to understand the configuration that you are what? Putting in. It's not to follow me and write the same thing I'm doing. You can do it in your own now while you are doing it. You can reference each what? Network. Isn't it? While I'm doing it, I can do this other one. The main thing is for you to understand. The first thing is done, the network. Then the last thing is the what? The area. OSPF has what we call what? Area. It's a kind of partitioning in OSPF where you say that similar group of routers, you put all of them inside the what? An area. Do we understand? By default, OSPF is grouped into area. So what do you use the area for? Similar group of routers that are close to each other. You put them inside what? An area. Another group of routers that are similar, you put them in another what? Area. So you can have multiple areas or you can have a single area network. If when we go into detail, you will find out the benefits of using multiple area when you compare it to using what? Single area. But as far as there is a pro, there will be a what? There will be a what? A con, isn't it? As far as there's a pro, there will be a disadvantage now. You are gaining something, and you are sacrificing what? Something, right? So if you want to use a single area in your network, there is something you are gaining and there is something you are sacrificing. If you want to use multiple area, there is something you are gaining and there is something you are what? Sacrificing. So for the basic one that we are doing, we don't need to create any area because by default, just like the way the instance has been created, a default area has also been what? Created. And that default area is called backbone. Are we following?
Backbone.
So anytime you hear OSPF, what should go in your mind is what? Backbone. By default, all OSPF, the first area 0, is called what? The backbone area. Are we there? So in my area command now, I can reference the backbone. Are you seeing it? Look at the screen. Backbone area. If you have other areas that you have added that is in a multiple area OSPF environment, you can reference them over here.
What does the backbone?
Area 0, the first area. By default now, just like the way you have the default OSPF instance, by default OSPF comes with what? In an area. It comes with an area because OSPF is an area-based routing protocol. You have different areas. So if you have not created the second area, by default you have the first what? Area. And that first area is nicknamed what? Backbone. Another name for it in some other devices is area 0 because that's the first area. Either it's area 0 or it's what? Backbone. So by doing this, on clicking enter at this point, my router now begins to look for what? It's not advertising OSPF on all these what? On the networks that you have mentioned. Note that on the networks that you have what? Mentioned. So that means if I put a particular network here, other networks that I did not put will not be what? Advertising neighborship. Do you understand? So I've done in, this is R1. To check for your neighbors, you do neighbor, right? Neighbor, sorry, I'm in network menu. I have to go back to the OSPF. OSPF neighbor print. You can see now that my neighbor menu is empty, isn't it? I don't have any friends yet, right? Now, if we repeat the same thing that we have done here on R2, the same thing we did on R1 to establish OSPF, I go to R2, and I open up my console. So this time around, I'll be quick with the configuration. If you don't understand it, now is the second chance to understand it though. So that thing has gone back again. Settle. How to write? Are we together? Are we together? Okay, oh, R2. So the first thing was to create a bridge, isn't it? Interface, bridge, add, name, equal to loop back. Then IP address, add, network key. Address is equal to 10.10.10.2. This is the router ID. Address now.
It's not IP address and interface equal to back.
Anyone interface, address or interface can come first. I can come back here and put interface, no wahala. Interface is equal to loop back. I used capital, loop back. The address is 10.10.10.2/32. That's step 2, right? Step 3, to set the router ID, isn't it? That one is in routing, OSPF, instance, set number 0, the router ID, and we set it to that IP address of 10.10.10.2, right? Then the last one is to announce the OSPF, isn't it? Which would now be in routing, OSPF, network, add. The network address is equal to 0.0.0.0/what? 0. And the area is equal to what? The backbone area. And that's all. If I look at routing, OSPF, neighbor,
For each router.
print. Now, do you now see now that we have form neighbor? Routing OSPF neighbor print. Do you see we have formed the neighbor with the first one? And do you see its router ID?
1.
Do you see the router ID coming from that router 1? This is router 2. We have formed OSPF neighborship with router 1. This is router ID 10.10.1. Okay.
So for each router, you do this.
For each router, we need these 4 commands.
Each router.
Yes.
We get 10 routers.
Hmm?
I want to have 10 routers. We do
Yes, now.
For each router, that's the
this for
ID.
Router ID. That's where we now in class that week. I don't even know whether the people I taught they followed up or I now taught them scripting in Microtic. They allowed to it. I taught us scripting now. See the way Zach is looking at me. I go, no worry, he says it all.
And what did you do?
So we could do it now.
each router.
Yeah, this is router 3 now. So in scripting, we are programming. That's what it means in scripting. Like programming. Now, if you look at all these commands, they are similar. The only thing that is changing is the router ID for each router. True or false? Mr. God bless. What are you doing? Pay attention.
Okay, the router ID will change.
If you look at these 4 commands, right? All of them is the same thing. Because when we start repeating them, let's say we have 200 routers to do these commands on. It will all be this line now. But the only thing that will be changing is the what? The router ID. Because in each router, we create a loopback. Isn't it? Same command. In each router, we assign that loopback interface, the IP address. And in each router, that IP address that we assign it, that's what we use as the router what? ID. Then based on that, we will now announce OSPF on all the networks. So with this now, we know that the only ID that is changing, the only thing that is changing is what? The loopback what? Address. Isn't it?
Yeah.
Isn't it? So based on that, we can then form a code. That loopback, that IP address, the loopback IP address can become what? A variable. Isn't it? It can become a variable now. It can become a variable. So that in programming now,
I think I changed
All right, look at the screen. So that in programming now, we can then write the code, because the same way that we are writing commands can be the same way programmers can program the router. True of us. That enables what we call software-defined networking. Software-defined networking. You've heard it before now. We've talked about it, right? We've talked about software-defined networking. Software-defined networking is the process where software is used in arranging or administering how the network should look like. And what is software? Programming, isn't it? What is software? Programming, that's all. So, in programming, they use variables, right? Temporary memory locations to hold the value, isn't it? In Microtik, to create a variable, you use a global, column global, and you put the name of the variable. You can call it my variable. Let's just do some things. Then I can assign a value to that variable using dollar set dollar my variable. I can set it to an IP address. We're in R2. I'm trying to build the one for R3. So my var can hold a value like 10.10.10.3, right? So if I should print put dollar my var, do you see returning that value that we set there? Am I confusing you guys? Everybody's quiet. It's not entering again. If it's not entering again, now go and do the configuration manually by yourself. Can't do the configuration by yourself. Interface bridge is even good that you're doing it manually. Interface bridge name. Sorry. Add name is equal to loopback. IP address, add the interface loopback. The address is router 3 10.10.10.3/32. Then
Or even if you don't put the /32,
it doesn't matter. Routing OSPF instance, isn't it?
Yeah.
Zach, have you done this thing in your topology? What are you doing now? Mr. God bless.
Yes, sir. You know that we were doing this. I think the system say we should look up first.
All right, let's start. You went to go and do this. No, please. You're doing what we are doing. You're doing it on the topology that you were using before. Don't use our own. This is expected under your topology. I'm showing you how to do it with this one. I've done it on my own, right? I cannot be doing it there because it's already working there. Routing OSPF instance, add, isn't it? Sorry. Look, okay, set the what? What are we setting? The router ID as 10.10.10.3, right? Hey, I didn't put the number 0.
You have to add there, is it necessary?
To add where?
IP add
IP address. I didn't complete it. IP address add. Then the last command to set up OSPF is routing OSPF network, right? Add network. Add network is equal to 0.0.0.0/0, and the what? The area is equal to what? Nobody the answer.
Backbone.
Backbone. Now, if I should check routing OSPF neighbor print, do you see now? I have two neighbors. I have from 10.10.10.2 and I have from 10.10.10. What?
What's one?
1.
So, Mr. Kevin, this IP you are adding on the router ID, are you the one giving the router the IP?
Yes, now that's what we did here now, this first one. That loopback IP is what you're going to use as a router ID. So that from somewhere, like see now, I'm in route 3, I'm seeing neighborship with two different routers. Once I see 10.10.10.2, I know that there is R2. Because that's the IP address we gave to what? R2. You see how it's making sense? You can easily identify, because from here now I can ping, I'm in R3, right? I can ping that IP 10.10.10.2. Are you seeing it responding? Because that IP is in what? R2. So as far as there is connection, to R2, as far as these people, this one here, I mean R3, for R3 to go to R2, it will go through .6, isn't it? Right? So as far as this .6 is active, that 10.10 will respond. As far as .1 is active, it will respond. Different paths to that same place. My last router is R4. Zach, have you started doing it? Bura, where are you? IP interface bridge add name is equal to loopback. The interface bridge add name is equal to loopback, then followed by what? The IP address add. IP address add. Interface is loopback. Address is what? 10.10.10.10.4/32. Then routing OSPF instance set number 0. Router ID is equal to 10.10.10.4. Routing OSPF network add network 0.0.0.0/0, and the area is equal to backbone. And at this point, I'm done with my routers. So IP route, can we look up, please? Look up IP route print. Now, from my routing table, do you see that I have a route to each loopback ID? Do you see it? I'm on router 4. I know how to get to 10.10.1, which is router 1, isn't it? I know how to get to 10.10.2, which is router 2. I also know how to get to 10.10.3, which is router what? 3. And each of them, you see that they'll be having different IP address. And for instance, let's please look up. No.
Absent. The other class. I saw this book in my class. In another class. Here's the class. Done.
Now, if you look at the flag, you can see that small o there, right? And up here, what is small o? Meaning that route was added via what? OSPF. If you look at number 1, do you see that thing I explained earlier? It's not shortest distance. Equal cost, multiple what? Path. ECMP. It means that the link that is going to 10.10.2 from arrow 4 has two different paths that are what? Equal. That is why instead of now adding one and making one back up, it did what? Load balanced it. Merge it as one. That's why you're not seeing that. To get to this 10.10.2 network, some packets can go through 13 and some packets can go through 22. And if you should relate that with our topology, we're in arrow 4. To get to arrow 2, some packets can go through 22 and some packets can go through what? 13. Is it making sense? So that if we pause here, for instance, if we should suspend this link, that means all the packets going to that network will now be going through here. Or they can go through here. Right? If I look at the routing table again, I see it there, it has updated. That it was 10.10.10.2 before, right? See it now. It's no longer load balanced. It's now going through only what? 13, which is the bottom link. That's the one via arrow 1, isn't it? Someone will ask, what of this link here? This link should be the most preferred link, right? Well, if you remember earlier, there was a time we disabled this link on arrow 2. Now, if we go to arrow 2, and confirm that interface print, do you see that link is what? Disabled. So that means interface enable 1. Sorry, that's number 0. Interface enable number 0.
Does it use index?
Yes, now see it here. Number. Okay. So if I print again, interface print, that link now is back running. Now if you should come back to our arrow 4, remember those links, to that arrow 2, it was going through 13. Now, if you come back and do a print now, this is that it has changed. It's now what? 18. Because it's now direct. It's not going what? Direct. It's only when this link fails, that's when to switch to these two backup links that are equal parts. I hope it's making sense, right? This is what I expect us to do. As you do this, you get used to.
After we configure the routers, the next thing is to do this bridge and OSP.
It's not. We don't call it bridge. We call it loopback.
So that is the next step to after we configure the.
Yes, now.
Yes, so because sir, I've not actually configured my own in such a way that
It's four commands.
So it's communicating directly, but it cannot communicate.